Yes, your Wi-Fi, your mobile, fiber tech, everything are the examples of wireless networks, right? What is the aim of all these networks? To connect one device to another so that you can communicate properly, right? So the basis of our network is data communication, right? So the word data over here represents some information, right? Represents some useful information. And the word data communication says exchange of data between two devices, right? Suppose there is computer one and computer two, right? So exchange of data between these two devices via what? This intermediate thing is known as transmission media, right? As you said, in case of telephone lines, these lines, these actual wires are the transmission media. Sometimes this medium is wireless, right? Sometimes we have optic fiber cables over here. Sometimes we have different sort of cables over here. So data communication after all means exchange of some data, sending some data from one PC to another or some from one device to any another device, let's say mobile or any modem or anything via some form of transmission medium. Now this transmission medium can be anything. It can be a wire cable, it can be wireless media, it can be Wi-Fi and so on, right? So when can you say that a particular data communication which is happening, that is particular exchange of data is effective? When can you say that the communication was effective, right? I can declare this when first aspect to be considered over here is delivery. That means two things are to be considered. First of all, the data which I am sending, suppose computer A wants to send data to computer B, so it should not reach to any other computer C, it should reach to B only, right? So the destination should be correct. And secondly, the receiver who is getting the message, let's say A and C both are getting the message, both of them should be authorized. What do you mean by authorized? On Google Classroom, what are you people authorized to do? You as a student. What are your authorities? And me as a faculty, what are my authorities? What is authorization? Authorization means if A is sending data to B and C, right? So B and C should be authorized. They should have the right, appropriate rights to access that document, right? For example, there is a faculty which is also taking this CN subject. Let's say faculty 1 and faculty 2. So I am supposed to uh, exchange the question paper with this only. Means suppose we are discussing the question paper, you people should not have the rights to see it. Right? You can only see the question paper when it is the time of exam. So this B and C as a student are not authorized to see the question paper, but the faculty F2 is authorized to edit the question paper. Are you getting? So according to delivery aspect, the destination should be correct. First of all, the data should reach only to the receiver who is intended to receive it. And also when the receiver is receiving it, he should have appropriate rights to access the document. He should be authorized to use that data, otherwise it is of no use, right? Then there is accuracy. What do you mean by accuracy? What do you mean by accuracy in general case? Yes, noise in the data should be less. And to deliver data accurately is whatever data you are sending from here, 100% same data should be reflected at the other side. Right? There should not be any distortions, no noise, no manipulation of data, right? So the data which we are sending should be received as it is on the other side, and that is what you mean by delivering some data accurately. Now, what do you understand by timeliness aspect of communication? The word itself indicates that the whatever data you are, yes, delays are not allowed strictly. Suppose I was supposed to deliver the question paper to the students at 2 p.m. sharp, and because of some errors in the network, it is reaching the students at 3 p.m. instead of 2 p.m. So 1 hour is wasted, right? So these delays are not at all allowed, right? At least wherever this second one is accuracy and third one is timeliness, right? Moving on, components of data communication, that is what hardware or what actual things are required for communicating one data from a particular sender to a particular receiver. Let's say the name of the sender is Alice and the name of the receiver is Bob, right? So Alice wants to send some data to Bob, right? So one of the components will be the sender, right? First component will be Alice's PC or mobile or anything. Second component will be uh, Bob's PC or the device on which he wants to receive the message, right? Third important component will be the media, right? Will be this intermediate media via which Alice would send a message to Bob, or you can say vice versa. There has to be some medium, right, to transfer data from one place to another. So that is one. That is the third aspect. Fourth aspect is protocol, right? What do you mean by protocol? We have heard this protocol term in general, right? So what is protocol? Does anybody know? Yeah, sequence of rules, or you can say protocol describes a set of rules, right? Suppose you are appearing for your end semester exams, and before that, uh, I'm supposed to upload some set of rules, right? That these are the rules to be followed during the exam. So this is a protocol related to our end semester exam. So sorry. In the similar way, we have a set of fixed rules for any data communication to happen over a network, right? And the fifth component over here is the message which you are sending from the sender towards the receiver or vice versa, right? So the five components are: first one is sender, second one is receiver, third one is your transmission media, fourth one is your protocol, and fifth one is your message which you are supposed to send. Any doubts up till now? Okay. Now, data representation. The data which we are considering over here, or the message which we are considering over here, how is it sent to the opposite party? In what forms do we have our message, or in what forms can we represent our data? Now, we already know that our computer understands only binary language, that is a sequence of zeros and ones. So, for corresponding to any character, how is text represented in any computer? Do you have any idea? Let's say I want to represent this thing, bits. How will the computer understand that it is B, I, T, and S? Because it does not know any natural language or characters or anything. So what does computer know? Yes, but corresponding to every character in my keyboard, what do I have? ASCII code. Perfect. So every key on your keyboard corresponds to an ASCII character. If I press B on my keyboard, it is having some ASCII value, let's say, that too in binary. So suppose it is 0 1 0 1 0. So computer will understand that B is pressed, because while I press B, it would be converted into its ASCII code, and so the machine can understand it, that the user is supposed to type this. Then I is having its own ASCII code, T is having its own, S is having its own. So in this way, you can convert each character into a sequence of zeros and ones, and this encoding is known as ASCII coding. What is the full form of ASCII? What is the full form for ASCII? It is American Standard Code for Information Interchange, right? So it is a standard given to us for conversion of every character to some number, which again is considered into binary, right? Now, number can also be represented via a sequence of bits in a similar way that we represented any symbol or characters, right? Now, how are images represented? Suppose there is an image. How does computer interpret that image? For any image under consideration, we would be having a bit pattern, or you can say every single unit is known as pixel. An image is always represented in 2D in traditional ways, and this one component is known as a pixel. And this pixel corresponds to either 0 or 1. So such a series of pixels will constitute an entire image. Okay? Now, similar is with the case of audio and video. Video is nothing but a collection of image frames, right? One frame, second frame, third frame at different time intervals will constitute a video. What about audio? How is audio represented in our system? How can computer interpret some audio which is given by a user? See, audio will be given to us in the form of signal, right? In the form of signals. Now, these signals are decoded into binary, right? There is something known as signal processing done inside our computer, right? So, let's say this is your signal, right? So, this represents 1, this represents 0, this represents 1. So, in this way, we have multiple encoding techniques which we would not go into detail currently, but you just have to remember that there is something known as signal processing or audio processing, with the help of which this audio information is also converted into binary by our computer or by our CPU. So data can be in the form of text, in the form of number, images, audio, and video. Right? Anything else that you can think of how the data can be represented? Now, three types of communications are possible for two different parties to communicate with each other, right? First type of communication is simplex, second one is half duplex, and third one is full duplex. In simplex communication, what happens? At one point of time, only one person can send the data to another, right? The other person cannot reply back, and the direction of data is only one. You can send the data in only one direction. There will be only one sender, and this person will always act as receiver only. Clear? Next, we have half duplex. In half duplex, suppose this is station 1 and the another party is station 2. Both of them are allowed to communicate with each other. Right? Station 1 can send the message to station 2 and vice versa, but they cannot do this simultaneously, or you can say at a single time. Right? So this indicates direction of data at time 1. That means at time 1, only one of the persons is allowed to send. If other person wants to send the data, it has to send the data at time. Let's say if this was time t1, this should be time t2, right? Now, advanced to both of these methods is what we call full duplex. In full duplex, what happens? Both the stations are allowed to send the data. Let us say this is station 1 and this one is station 2. So both of them are allowed to send the data and at the same time, right? At time t1 only, station 1 can send the data over here. At time t2, at the same time, station 2 can reply as well. So clear with different modes of communication. All these three things are nothing but modes of communication. If you are asked in exam, that please write down possible modes of communication in computer networks or in basic computers. So we have three modes: simplex, full duplex, and half duplex. Clear? Moving on. Now, what is a network? Right? A network is a set of devices connected by communication links. That means two things will be combined to form up one network. Let's say this is one device, this is second, third, fourth, and fifth. So these are what? A set of devices, and they all must be connected by communication link. This is nothing but your transmission media. So this entire thing will sum up to form a network. So network is nothing but a set of devices plus some links to connect them. Simple as that. Now, what do they refer by this node? You can call it a set of devices or a set of nodes. That means a node can be anything. It can be a computer, it can be a simple monitor, it can be a printer, right? In short, any device which has the capability of sending or receiving the data from the other nodes on the network, right? Printer can send the data. You can always send the data from the keyboard towards the monitor. So keyboard can act as one node. Also, you can have a dedicated computer as one node. You can have a dedicated second computer as another node, and so on. So in short, a network is a collection of nodes plus some devices to connect it, provided that each and every device should have the capability of sending or receiving data from the network, right? And or is more appropriate. Some devices can send and receive both. Some devices can only send. Some devices can only receive, right? Now, types of connections, right? Now, uh, two different types of connections are there. First one is point to point. Second one is a multi-point connection, right? Two devices connected with each other, simply it is known as connection. But when it is known as point to point, when between device 1 and device 2 you only have a single link, means one link is there and only two stations are allowed to communicate with each other over that single link, right? So that is point to point. And sometimes we have a multi-point link that with same transmission media, three different stations are connected and a mainframe computer as well. That means it might be having some higher processing capabilities or abilities, right? So where multiple stations or multiple devices or nodes are connected with one link, we call it a multi-point connection. And point-to-point connection is when only two stations can be connected via a single link. That is, a dedicated link should be present between any two devices under consideration. Right? Now, next topic is what? Topology. Topology is the way how the network is connected, right? Do you know any of the topologies existing currently? Since you all might be using Wi-Fi in your homes, you all might have been to some computer labs for any of the subjects. Yes, star topology. What is star topology? Bus, ring. Yes, right. When there are many devices, that is two or more devices, and there are many links, that is two or more links, then we can say that they would collectively form a topology. Topology is the way you can connect some devices. Suppose there are three devices over here. Sometimes I would require that all the devices would be connected to each other, right? So this would be connected to this two, this would be connected to this two, and so on. Another type of topology can be first device is connected to second and second is connected to third. So it is nothing but the way the network is laid out physically, and that is what we call topology. The way we connect these devices can be many, there can be many ways. So according to that, the classification of topology has been done, right? So there are four categories of topology: mesh topology, star topology, bus, and ring topology. So starting with bus topology, does anybody know what happens in bus topology? Vatsal has given the name bus topology. Do you know how does it work? Yeah, one main line and many receivers. How does the bus topology work? There would be a single connection line, there would be a single transmission media, and n number of devices would be connected over here. So this main link which you are connecting through is known as bus, right? And these are the links connecting each of the devices to this bus. And for connecting each of the devices to the bus, you need something known as connector. So in case of bus topology, what would be the number of connectors? See, if it is bus topology, let's say three devices are connected. This is known as link, right? This thing is known as bus, and the thing via which you connect this is known as a connector, right? So if I say that n number of devices are given to you, then what would be the number of links? See, this is itself is also considered as a link. So in bus topology, what would be the number of links under consideration? See, for attaching n devices to the to a single bus, right? I need n links, and if I consider this one also as a link, it would be n plus one links in total. right? In some of the sources, it will be given only n links. Some says that it is n plus 1, but it is all about perspective. If you consider this one also as a link, then it would be definitely n plus 1, right? Now, what would be the number of connectors if the number of devices are n? Yes, simple as that. If I want to connect n devices to a bus, the number of connectors required would also be n, right? Now, let us analyze how does a communication happen over a bus topology, right? Can you guess how, suppose the names given to these stations are 1, 2, and 3. What if station 1 wants to send a message to station 3? How can station 1 send the data to station 3 only? See, what happens in a bus topology is a single link is there to share your data as well. Let's say at 10 a.m., no, permission sort of thing comes when you have some software included over here. Currently, we are assuming that we have only a set of wires which is connecting us to other stations, right? So, yes, Harsh, I am not getting you. What won't happen? Yes, Harsh. Yes, that was my point. If any station out of this 1, 2, and 3, if it wants to send some data to any other station, it has to send the entire message on this link. It would put this message on this link, right? And every station, including 2, 3, 4, 5, whatever might be there, everybody will receive the data. Now, if they are supposed to get that data, because in some kind of messages, there might be some destination address that I want to send the data to station 3. Let's say here our destination address is 3. So 2, 3, 4, 5, everybody would receive the data, right? First, what will happen? They will get the data. Then they will compare their own destination address, right? Here the destination address is 2. It will compare the destination address with this one. Are they same? No. So it is not supposed to download that data, right? Then 3 will compare its own destination address to find out that was the data intended for me? Yes. If yes, it will keep the data, right? 2 will reject it, 3 will accept. Similarly, what about 4 and 5? 4 and 5 will also compare address, so they will also reject the data, right? So now can you tell me what are the advantages, what can be the advantages of this topology and what can be the disadvantages? One single advantage of using bus topology. Okay, if you can't figure out an advantage right now, tell me the disadvantages. Yes, it is easy to install. Then cost effective, because we need only a single line. Very good. It is simple to implement. Yes. It is not a complex thing. Any right? So we have certain advantages like it is easy to install, cost effective, and simple to implement. Let us keep it to this much only. Talk about disadvantages. What about disadvantages of using a bus topology? If the bus fails or gets damaged, the whole network will fail. Yes, this is the main disadvantage, right? And this is what you call single point of failure. Single point of failure is a characteristic which says that if one of the components fail during the transmission, right, then uh, none of the transmissions can take place because this was the main line through which communication was supposed to happen. If this and this line fail, then the other stations can communicate as well. But if this main cable fails or it is getting damaged, then no station can communicate to each other. Second point is Vishal, can you explain your point? I am not getting what you are trying to say. Okay, fine. Now, Harsh wants to say that time takes a lot for data transmission. Definitely, time required is very much high. We cannot expect fast transmission. So, one of the disadvantages may be delay in transmission. What about collision? Have you heard this term? Do you think some data will collide with each other? Because here there is no sort of communication that I will send the data first, you will go second, you will go third. What if all these three stations are sending the data at the same time or simultaneously? What will happen? The data which they are sending on this link, we have a common link. All of them are trying to send the data at a single time because there is no provision to coordinate with each other in advance that who will send the data when, right? So all this data, if sent simultaneously, will collide with each other. And thereby the accuracy will be affected. Any other advantages or disadvantages that you can think of? So we are clear with bus topologies, right? What is the architecture of bus topology? How does it work? What are the advantages and what are the disadvantages? So this type of questions can come up in your exams that explain and justify what are the disadvantages of bus topology or what are the advantages over another, right? Yes, definitely everyone will receive the data. So it might lead to some security issues because the data was intended for only station 3. Then why station 2 receiving it, right? So these are some issues which can come up. So I think it is all for today. And whatever topics we have learned today, do you have any doubts in that? Because we need to clear the basics first to move ahead. So if you have any doubt up till today's content, you can ask me because we are going to cover another topologies in the next lecture. Okay, nobody's having doubts then? Okay, Vishal, just a second. Which slide should I go up to? This is the content which we have covered. We have not gone through mesh topology. We have not gone through star topology. We have only covered bus topology. We have only done this mesh today. So in which topic you are having now? Okay, okay. We have only discussed bus topology because it was the simplest, right? We would move to other topologies in detail in the next lecture. Does anybody else have any doubt? Okay, I suppose nobody else is having doubt. So you all can leave the meeting. We'll continue in the next lecture.